All right, part 2 of week 7. I said at the beginning of the last video that this was going to be the harder part of the week, and yeah, it is, because you're looking at this and you're seeing a whole bunch of words and you're seeing a whole bunch of things that mean math, right? And it's kind of hard sometimes to figure out exactly what they mean and how it translates into an equation of some sort. But it's just something that we need to do. And if you go out and Google search for words that mean math operations, you'll find all kinds of lists of words that mean different things like add, subtract, multiply, and divide. Okay? If you need to do that and have that list handy, go ahead and do it. That's perfectly fine if you want to have something like that sitting by you when you're doing these. But the way these work is we just have to kind of figure out what means what, right? So if we think about how we would translate this, quotient is that fancy word for divide, right? And that's the division symbol, but more often than not, we're going to think quotient in terms of a fraction. Okay, so a quotient would be something like a over b. That's a fraction, where a and b are just numbers, right? Of a number, anytime you see a number, that represents a variable of some sort, x. Minus, hopefully this one's pretty straightforward, it means minus. And then we have that word quotient again, so that means divide of, the number, that means x again. Okay, and then, and 10. There's one that I forgot that's kind of an important one that I skipped over, and that's this one right here, is. Is generally means equals. Okay, so you can see right here we have something that divides this sentence into two parts. So we have the two parts are going to be here. This is the left-hand side of our equation, and this is the right-hand side of our equation. So if we can just kind of identify that dividing point with the word is, we can then kind of put things together and say, hey, I can create an equation of some sort. So I'm going to try and do this and not make it too terribly large here to take up all my space. But all right, so the quotient of a number and 5. Anytime you see something like that, it's basically saying, hey, the fraction of a number divided by 5. Okay, so it's basically, it's going to be x over 5. And then it says minus 3 halves. So we got minus 3 over 2. Okay, so this is the entire left-hand side of the equation. The quotient of a number and 5 minus 3 over 2 is equal to the quotient of the number and 10. So that's basically the same as the beginning of the other one. So we're just going to create another fraction of the quotient of the number and 10. So there we go. We just translated those words into an equation of some sort. And this is a equation with rational expressions in it, so we multiply by the LCD. In this case, hopefully the 10 is obviously the LCD, so we're going to multiply everything by 10. So we end up with 10x over 5. Now some of you like to do this simplifying as you're doing these, and that's perfectly fine. And then we have 30 over 2, and then we have 10x over 10. I'm just showing the full steps, so if people are like, hey, wait a minute, what did you do to get this? That's perfectly fine. If you want to skip this step, you can. But just make sure you don't forget something as you're doing that. All right, so now what we can do is just simplify, right? So these 10s are going to cancel each other out. So my right-hand side of my equation is just going to be x. And then the left-hand side, 10 divided by 5 is 2, so this is going to become a 2, and 30 divided by 2 is 15. So what we're going to end up with is 2x. So let's see here. I'm going to go up here. 2x minus 15 equals x. All right, and now from the last video, I said, hey, when you got multiple variables like this, you always want to start with the smallest one. Well, in this case, this is one where if you started with the smallest one, it would actually make more work for you. So I'm going to start with the bigger one. I need to subtract 2x. And I can't avoid the negative numbers this time, so I'm going to have negative 15 is equal to negative x. But then in this case, all I have to do is say if they're both negative, the mathematical way is divide by -1, but the common sense way is just like, hey, if they're both negative, that means that the answer is positive. So it's x is equal to 15. Okay, so there we go. That is an example of how we can solve a problem about numbers by translating words into an equation of some sort. All right, let's do another one. 3 times the reciprocal of a number equals 9 times the reciprocal. Oh, let's do this. Let's just identify the dividing point, right? So the dividing point here is that word equals. So we know right here, it's right here. So everything here is the left side of our equation. Everything here is the right side of our equation. And so let's work on one side versus the other. So 3 times the reciprocal of a number. 3 times the reciprocal of a number. All right, so this is going to be 3 times the reciprocal of a number. If we remember what the word reciprocal means, it means to flip something upside down, right? So if our number is x, we want the reciprocal of x, which means we flip x over and put a 1 over it. Okay, so we have 3 times 1 over x. Well, that's kind of a messy way to write this. And so what we can do is just multiply the 3 and the 1. So we end up with 3 over x. Okay, so I'm going to get rid of this by doing that. Hope that's okay. So 3 over x is equal to 9 times the reciprocal of 6. Well, 9 times the reciprocal of 6 would be 9 times 1 over 6. But again, it's kind of a messy way to write it, so I'm just going to write it as 9 over 6, and I'm going to get rid of that. So now we have a relatively simple proportion that we can solve, and this is one where we could look at it and figure it out. Or we could cross multiply. So let's just cross multiply. So we're going to do 9 times x is equal to 3 times 6, or 18. And then we divide by 9 to get x equals 2. Okay. Reciprocal is always a tough one. So if you struggled with understanding this one, that's okay. But just remember the reciprocal of anything. The reciprocal of 5 is 1 over 5. The reciprocal of x is 1 over x. Okay, so it's basically just taking this thing and flipping it over. So if we put them over 1, we can see we're just flipping them over. All right, last one. 4 times a number added to 5 is divided by 6. The result is equal to 7 halves. Woof. Okay, so I said is means equals, but in this case we have is used in a different way. So the is in the first part of this is not going to mean equals. Where we're going to see the equals is, whoops, the result is equal to. So like right here, it's saying the equal part. The result is equal. So this is where our equal is. So that means our equation is the right side is there, the left side is there. Okay, so the right side is easier, 7 halves. Whenever somebody says 7 halves, or any number halves, it just means that number divided by 2. So this is 7 over 2. And then let's figure out the left-hand side. 4 times a number added to 5. 4 times a number added to 5 is divided by 6. Now, this one we got to be a little careful. 4 times a number, 4x plus 5. And then where it says is divided by 6 means that, hey, this whole thing is divided by 6. So we got to divide this whole thing by 6 like that. Okay, so let's see here if I can move that. Nope, let's not do that. Here we go, let's do it again. Okay, so there we go. And then I'm going to move this a little bit. So this one was a little trickier because we have to kind of translate this idea of, hey, we're doing the 4 times a number added to 5 before we divide it by 6. Okay, so and the key here is that word is. 4 times a number added to 5 is divided by 6. All right. If that is wasn't there, what we would have is 4x plus 5 over 6. Okay, so if the is wasn't there, it would be, it would be 4x plus 5 over 6. But the is tells us to make sure we divide everything by 6. Okay, so I'm going to get rid of that. We don't want that. All right, and so then here, it's a matter of cross multiplying. So we're just going to cross multiply, do those two. Key here is this is a binomial, so we need parentheses. And when we cross multiply, we end up with 2 times 4x plus 5 equals 7 times 6, or 42. Now there's a bunch of different ways we could solve this, but most of you are probably looking at this and saying distributing, so I'm going to just go ahead and distribute. So we have 8x plus 10 equals 42. Oh goodness, I'm almost out of room. Subtract 10. So we have 8x equals 32. And then this one ends up being a nice neat number because 32 divided by 8 is 4. So x is equal to 4. All right, not a ton of these for you to do, only 4 of them, but they're tricky. So see if you can do them and have some fun with them.